Hey everyone, I'm Kshitij, co-founder and CTO here at Orb. Welcome to another episode of Tractable. Today I have with me Gwen. Gwen is the co-founder of Nile, which is a serverless Postgres offering for modern SaaS applications. Previously, Gwen was an engineering leader and architect at Confluent, leading the cloud-native Kafka team. Gwen, really excited to have you. Thank you for coming on the show.
So exciting to do this with you. Thanks for
Uh,
inviting me.
Of course. Yeah, I think we're going to have quite a rich conversation. But maybe before we dive into Nile and the architecture, I'd love to just hear a little bit about your background and what you've done leading up to Nile. And then I'm sure we'll incorporate that into the rest of the chat as well.
Yeah, so my background has been software engineering and especially in the data space. So basically I'm old, so many years ago, I took a job as a software engineer and then the data architect left and I was asked to fill in, and basically the company hired someone who was more senior. I learned a lot from them. And basically from there on, I just did data. So starting with Oracle and then a bit of MySQL. And then when basically big data became a thing, I started doing Hadoops. And from there to streaming data with Kafka and Confluent. And now we're doing serverless Postgres at Nile. So I guess my entire career is all databases all the time.
Yeah, that's interesting. I think you've seen a lot of those trends honestly, some of the leading companies at the time that those trends were really popular. And obviously, I want to dig more into Nile as a point because that's what you're currently working on. As I understand it, Nile's core architecture is predicated and based around this idea of native multi-tenancy. So maybe we can start there. Can you give us some background on what that means? What is native multi-tenancy? And maybe we'll start with the use case of like, why is that so important in B2B software? And then we can talk about like at a technical level, what implications that has.
By saying the obvious, but if you're a B2B SaaS, you have customers. And those customers they may be small, they may be big, you may have mix of sizes, but they're really critical to everything you do around your business, around your service, around everything that you provide. And they're going to be quite central to your data model as well. And there are tons and tons of companies like that. One may say even most of them. And then it comes as a surprise once you start thinking about it. Like, how come our databases don't know about this core idea
Mm-hmm.
of a business? And this is a thing that was around from the beginning of databases, like 40 years. And
Right.
for 40 years, or in my case, I'm not that old, so maybe for 20 plus years, through all those databases, all those different data systems, every single time, do we want to give a database for each customer, which gives us a lot of flexibility and a lot of isolation and good security? Or do we want to do the multi-tenant thing and just put all customers in the same database, and if they grow, we'll shard it out,
Mm-hmm.
essentially? And every one of those has pros and cons. If you have bigger customers, you probably want to dedicate more resources for them. They're more sensitive. They may ask you to do more things like, please restore my database.
Right.
And if you have tons of customers, you probably don't really want to run 100,000 different databases. So you don't do that. But then if you have a database per customer, you cannot really run large reports.
Right.
So you have to balance a bunch of trade-offs. And when you get started, you don't even quite know what the trade-offs will be. Like so
Yeah.
many companies, like, yeah, I thought I'll go after very large enterprise companies, but guess what? I couldn't. So I went and sold to 5,000 small companies.
Yeah.
Basically, we're like, you probably want to design around those concerns. And when you talk to a lot of companies that serve customers, which again is pretty much everyone, you
Yeah.
keep running into these things where there are massive incidents around, I tried to do something for one customer, but then everything blew up.
Yeah.
Or we had one customer grow really large or had more traffic than we expected, and suddenly everything went on fire. Very obvious that to us that there is a need to give the programming models that developers like, which is the multi-tenant, shove all customers into the
Yeah.
same database, but still deliver the kind of functionality that provides isolation, that provides scalability,
Yeah.
that provides predictable performance, all those security, privacy, all those things you want the best of both worlds.
Yeah.
So this is basically what Nile is trying to do, to minimize the trade-offs, give a really nice developer experience, and give all the capabilities you would get from isolated customers,
Yeah.
and also all the capabilities and cost savings you would get from the multi-tenant model.
Yeah.
And we call it virtual tenant databases. That's
Mm.
our key idea. We put the multiple small databases with a lot of isolation deep inside Postgres. So our entire architecture is derived from the idea that if you could, you would really want 1,000 different databases,
Yeah.
but you don't want the trade-offs involved with doing it. So
Yeah.
we are going to give you the both.
And one thing I want to talk about is how this differs from a journey a company might go through on their own, right? So lots of companies, as you were just saying, maybe they start out with one, let's call it a Postgres database, and they vertically scale it until they run out of instance sizes, and then they realize, oh crap, we have to now shard this database. Maybe their data model already is shard aware, maybe it's not. They have to rearrange their business logic. Now they have 2 or 3 or 10 or 100 databases. And of course, there's a bunch of now management overhead on the DevOps side of thinking about multiple databases. But also, oftentimes, if you're getting to this place in a path dependent way, maybe there's a bunch of business logic or application layer code that also has to think about these databases being separate, distinct entities. So tell me a little bit of like, how would something like Nile, having used this as the starting point, differ from a setup where you've gone through the sharding process and maybe you solved the scalability and isolation problem? What is the distinction there?
Yeah, so that's exactly what we're trying to solve, because we've all been through this journey
Right.
so many times. So you start with basically I'll put multi-tenant model, I'll put a tenant ID over everything. First of all, we auto shard it for you. Without doing anything, you will actually run on a bunch of physical machines and get
Mm.
all the CPUs.
Mm-hmm.
This is straight out of the box. The second thing is that we actually force you on a specific programming model where when you make the connection,
Mm-hmm.
you specify what tenant you're connecting to. And we also give you the option to specify which user this connection is for. And we have an
Mm-hmm.
SDK that kind of takes it all the way from the browser, the user identity. And then we even validate, hey, yes, this user is allowed to get a connection to
Mm-hmm.
this virtual tenant database. We do the routing for you to the correct shard, obviously. The data is isolated. The moment that you're saying, I'm connecting to this tenant, no matter what query you write, you will not see any data that belongs to anyone else.
Yeah.
So it saves you from a whole variety of testing and mistakes that can be made and so on. So this is useful.
Yeah.
And then as you grow, we shard things for you.
Yeah.
Now, sometimes you get customers with special requirements, right? Let's say you have someone who really needs to be on their own device, or they already tell you they're going to need vast amounts of memory or whatever requirements they have. They want to be in a data center in Singapore, for
Yeah.
that matter.
Yeah.
It's all of this is basically either a single click or a single SQL command,
Yeah.
update tenant set region equals, and that's it.
Yeah.
So it replaces having to basically we're saving you from having to build Nile yourself,
Yeah.
which we've all built several times in our career
Yeah.
and feel like it's time to stop doing it again and again.
Yeah, one thing that I find interesting is when you build something yourself, one advantage that you have is that you understand the trade-offs you've made. So one thing I'm curious for your opinion on, is there a point where this multi-tenancy setup might get too magical or abstract away too much? And I'll give you some examples. Let's say that, I don't know if Nile does this today, but let's say you go so far as to have, I don't know, different encryption standards on different databases, or even like different indexes because the workloads for each tenant are different. One concern I have is that might end you in a place where it's hard to reason about predictable performance because you don't necessarily have the mental model of, oh yeah, this database performs like this in this workload in this test because Nile has done some magic for us under the hood that maybe the queries are optimized for that, right? So I'm curious, do you think that's a problem or a concern, or do you think trying to take away or abstract this tenancy concept, even in the face of those potential challenges, is still net very beneficial?
Yeah, so this is something that we run into a lot when we ran Kafka as a service at Confluent,
Okay.
because some people don't really care about the internals. They are
Yeah.
small teams trying to move fast. They prefer not to think a lot about Kafka or not to think a lot about how Postgres is going to scale for them and how to tune and optimize and so on. And then a lot of magic is absolutely the right amount of magic for them.
Yeah.
On the other side of the spectrum, we absolutely ran into customers who are like, it was especially a problem. My team shipped auto scaling,
Hmm.
and a lot of customers are like, I do not want you to auto scale for me. I have my own algorithms. I have my own experience. I know when I want to scale, and it will scale when I tell it to. And if I don't tell it to, it should not scale.
Right.
And we understand that. And we think that even if you absolutely don't want it to auto scale and you want to control everything, we can still make it easier on you. Make
Right.
it a nice update, tenant set capacity or something, and it will not be a whole operation that takes weeks
Yeah.
before a big event.
Yeah.
So we also hope to help those people. And then there's definitely people who really, some people are DBA. They're
Yeah.
really attached to actually running their own database and making every single decision. And some of them are incredibly good at it and and they've been in the company for a long time. They know exactly what they're doing. The company will never replace someone like that. And
Yeah.
this is fine. There is so many other Postgres in the world. Nile does not have to be for people who don't derive value from Nile.
Right. Yeah, that makes sense. I like that. It sounds like it's a matter of Nile gives you the tools to do something like this safely, but you can still tweak the defaults such that you don't have to opt into every single piece of functionality or every single auto optimization under the hood, right?
Exactly.
It's interesting to start with multi-tenancy as the kind of root of the architecture. Did you have a sense of like other different points that you thought were equally as important in modern B2B SaaS? I'm curious, was it your background at Confluent and maybe your co-founders that motivated the multi-tenancy specifically, or did you think through, okay, exhaustively, what part of the programming model is broken and multi-tenancy just fell out as, okay, this is
I
clearly the
wish,
thing that's
yeah,
broken.
it was definitely a journey. So when we started out, the only thing we knew is that Confluent had about 3 times more people working on SaaS, on the cloud
Hmm.
infrastructure, than it had working on Kafka, which was
Wow.
the core product. And this, even though we are the people who hired them, we knew that they were all needed, it didn't feel exactly right that this is the state of the world. So we're like, we have to find a way to make SaaS easier.
Hmm.
It cannot possibly require hundreds of people over years to build a SaaS product.
Hmm.
And then when we started, we played with a lot of ideas. We started with kind of a workflow manager, and we had some ideas from Kubernetes on how to integrate it with control plane. And
Hmm.
this seemed pretty promising, but we had a hard time taking it off as a
Hmm.
business, I would say.
Hmm.
Like we were struggling with product market fit. People understood Kubernetes in different ways. They didn't
Right.
quite knew what we were talking about. And
Right.
then one day we talked to actually one of our early design partners, and we explained something that we're doing for time maybe 100.
Yeah.
And then he said, oh, so I basically need to use you as a database. And
Yeah.
we're like, yes, exactly. You need to store all this information here, and then you get all this value about data access. And you could see the light bulb go off. And then we went back from that meeting, and I still remember like me, Ram, and also Norwood, who is our technical founder. We were like, huh. So we're like a database, yes? And building a database has so many advantages, right? Because you can enforce things at a layer that
Mm.
nobody can really get around, like nobody
Hmm.
can accidentally leak tenant data. we can solve all those problems we're seeing other companies have around sharding, around what if I need to restore data to one tenant in this multi-tenancy model. Like it just, stuff started clicking into place. If we do this, those different regions, we can put tenants in different regions, and that's a big deal for a lot of people. So yeah, it all coalesced together. So I guess it was both our experience, but also things came into place. And also building a database has the huge advantage for a company that your
Right.
customers will not want to build a database themselves. They
Yeah.
may choose a different Postgres, which is fine, but they're not going to say, nice idea, I'm going to do it myself.
Yeah, and not only does every company need some sort of database, but I think to your point, every company, it is very easy to resonate with this problem of I have end customers, I need to organize their data potentially differently, and so this is something I know I will run into at some point, at least in the happy path successful outcome.
Yeah.
So let's take one step deeper into the technical architecture. I was reading more about Nile's architecture under the hood, so I noticed that you push, and you mentioned this briefly, you push the multi-tenancy story all the way to the page level in Postgres. So
Exactly.
let's talk about that. And maybe just for background or context, let's say I'm just using regular Postgres, single machine deployment. Where does my data live in that world? And then how is this different in something like Nile?
Yeah, so basically when you do create table, then the table gets placed on a default table space. A table space is basically a bunch of files in disks. The file has blocks. Your table is basically a series of blocks in this file. Every row fits into one or more of those blocks. And then when you do select, the database goes to the file via an index or something similar, picks the correct blocks, puts them to memory, then they stay in memory as cache for as long as you use them. But it's essentially the same blocks of data in memory
Mm-hmm.
on our disk. And if you do the multi-tenant as people normally do, then you are very likely to have single blocks that mix a bunch of data. This is almost considered taken for granted.
Mm-hmm.
And obviously, you'll need a bunch of conditions to make sure that you're not selecting someone else's data. So, where you
Mm-hmm.
do this, where you do that. And then, because everything is mixed up in the same physical blocks, and those are the blocks that get backed up and everything, then if you need to restore tenant, then it's a bunch of pain. How do you do
Right.
that? If you need to move the data of one tenant to somewhere else, that's going to be a bit of a problem. So for now, we basically re-architected the concept of the table spaces,
Okay.
essentially. And we make sure that when you create a table, it's actually not necessarily a single file. It actually, basically every time you insert tenant's data into that table, we make sure that you have at least one file for that tenant on that table, and we make sure that your data gets stored both in memory and on disk,
Mm-hmm.
with the idea that your data is 100% fully isolated.
Mm-hmm. Got it. And so that's interesting because how should I think about the change that Nile has made to Postgres? Is it true that this is a change to the storage layer and not the query engine, or am I thinking about that wrong? Like, at what level of abstraction have things changed?
Yeah, we actually changed things in quite a few levels of
Okay, okay,
abstraction.
yeah,
First of all, yeah, the storage layer changed. We have our own storage manager.
okay,
And then at the query layer, we actually have not changed a ton, but we are nearing a point where we'll have to. One of the things that when, for example, let's say that you connect as a developer and you want to run a report across many tenants, you actually need to convert select star from
mm,
all the data to a
yeah,
lot of smaller queries that get distributed to all those separate virtual tenant databases. So it's a bit like when you select from a partition table,
right,
essentially, and it has to go over all the partitions. So that's a good way to think about it. So
right,
that's part of it. And then even before that, we have a proxy and a router to make sure that your query gets routed correctly. Yeah, we basically, and then we have an entire transactional system to handle. We don't do distributed transactions because we assume that most transactions will belong to a single tenant. But when it comes to DDL, which in Postgres is transactional,
mm-hmm.
we do have to make sure that you can do a transactional create table and
Right.
create indexes and all those things. So we actually have a distributed engine that is plugged in as an extension to the hooks that Postgres uses both for DDLs and for transactions.
That's interesting. So if I use an instance of Nile today, I sign up for your SaaS offering, and I make a query. That query needs to get routed to the right physical instance, and that routing, or maybe just even that lookup table, is that metadata store, let's call it, hosted on your end? To what extent is this like a fully managed offering versus I can see some of those internals and play around with them? Give me a sense of like how much of that is abstracted away from me.
The placement of tenants is very abstracted away from you at the
Okay.
moment. We do want to expose some decisions. So, for example, region is something you'll want to decide about.
Yeah.
Whether the tenant is placed with other tenants or you want to give this tenant some dedicated compute power, this is something that you get to decide about. But
Interesting.
we did the placement is something we abstracted, and with the idea that this is exactly when you need more capacity, we believe what you'll want to do is tell us, hey, I want more capacity, and
Yeah.
not necessarily decide which tenant you want to move to use that new capacity.
Yeah. Yeah, this is all it's all quite interesting because I think in a lot of ways most technologies seem to be moving in this direction where you only want someone to have to think about a piece of complexity when it actually matters to them rather than upfront. I'm sure you saw this at Confluent where as you were saying in the when you're starting with Kafka, maybe you want to think of it as just message in, message out. And then maybe you want to think about partitioning or repartitioning. And then maybe you want to think about multiple consumer groups or whatever the axis of complexity that's increasing is. So I'm curious, has there been anything as you've been developing Nile that you've been surprised, oh, people care about this, and I thought we could abstract it away? Or maybe even the opposite. Has anything surprised you in that sense?
And not as much in what people care about. Like maybe even the reverse. Like usually we think people will care about stuff that they end up barely using. Like I thought people use explain plans a lot more than they actually do.
Yeah.
So yeah, and most people don't even care about transactional guarantees. And we lost so many nightless nights over that, and then so many people don't care about it. So I would say the reverse is
Yeah.
the case.
Yeah.
I'm trying to think if we had cases where people cared about things more than we expected, and I think we
Yeah.
care about things a lot, probably more than our customers.
Yeah, that's one thing that I am guessing is very hard about building a database offering, which is every single customer you have must care in very different ways about parts of the product, right? As you're saying, maybe a lot of people don't care about transactional guarantees. Maybe some people really care about region placement, right? And that's going to be a strong feature request from them because maybe for compliance reasons. Some people care a lot about, I don't know, performance. And so you might really optimize things like cache locality or shard placement or something like that. So yeah, that just seems like a fundamentally a pretty hard problem to
Yes.
tackle as a small company trying to productionize this this database. So how do you think about navigating that as a just as like a product exercise?
Yeah. So our core belief is that if we build the correct building blocks and do a really good job on the infrastructure, other stuff will just magically work,
Mm,
essentially. And in many ways, this has proven itself out. So if you build distributed DDLs correctly, it makes growing to other regions way easier. You
mm,
have the correct transactional capabilities to even to go long distance.
mm,
If you do a bunch of hacks, usually you'll need to rewrite your hacks every time product discovers something. We really hired a team with really deep experts, tons of experience, and they built the best architectures that they knew based
mm.
on, I don't know, probably 100 collective years of experience building databases.
Yeah.
And a lot of those things that, yeah, some people will care about X, and they already took into account. I remember one really good example. I went to one of our top engineers and
Mm,
asked, I don't understand why you are doing this transaction thing the way you're doing in distributed transaction model. And
Mm.
he said, Gwen, one of the biggest problems in databases is that someone takes a look on a table and then goes to have coffee.
Mm.
And in the 5 minutes in which he's getting coffee, effectively production is down.
Right.
So I'm going to do something with a lot of lock timeout. We're going to avoid the someone going to get coffee problem.
Yeah.
And, and it's fantastic. Yeah. And so Nile solves the someone did something and went to get coffee and now what do you do problem.
Yeah.
So I think that really having those experienced people on the team is such a key to anticipating wide range of customer problems that a single founder will definitely never think
Yeah.
of, and then tackling them very early on from the architecture level.
Yeah, that makes a lot of sense. And I'm imagining one thing that helps somewhat with this, although I'm curious how much mileage you get out of it, is the fact that you're still building on Postgres, right? So maybe tell us a little bit about that decision. I could imagine a world, and I don't know if you all ever thought about it, where you build this more from scratch, right? Everything is from scratch, multi-tenancy is baked into the query engine, and entirely you don't use the Postgres query engine. Um, was that ever a consideration, or how much was Postgres being the starting point just obvious to you, especially now that Postgres is quite popular,
Yeah, I would say we haven't for 1 second considered building it from scratch. What we did consider for a while is to build on MongoDB, which is again another really popular
right?
data store for SaaS, and we thought that maybe this would be a good bet. But Postgres architecture is really amazing. And there is something like the way that they made it extensible and a lot of hooks in the product and the way that it felt like a product that evolves very responsibly. Like they've been
Mm,
evolving for 35 years,
yeah,
tons of use cases. They have really good project governance around that. Yeah, the moment we saw what Postgres lets us do,
yeah,
we were like, this is amazing. We have to do
yeah.
that.
Yeah, that's interesting because it sounds like it's a combination of technical architecture as well as community adoption and like you're saying, project governance. So across the board, I'm guessing this is why Postgres is such a popular database to build on top of or build on, because you have all of these things coming together, right? Um,
Yes, exactly.
the other obvious consideration when you're building a database is reliability, right? Everyone cares about this. If people are going to depend on you in production, it's a big burden to bear, right? How has that been part of the journey so far? Is that something that, like you answered the other topic, is it every incremental architecture decision just has to take it into account in some deep way? Or do you think there's some overarching way you think about reliability separate from evolution and feature development and other parts of your roadmap?
Yeah, for us, it's, as you said, a very basic requirement.
Right.
It's not exactly someone saying you can just tack on. And this was, again, something that was really drilled into me at Confluent.
Hmm.
We had an amazing VP engineering called Ganesh. And he basically, I think every meeting, he kept saying, nobody cares about all your features if the database, if Kafka is down. And
Right.
the same is true for databases. It doesn't matter how multi-tenant we are, if you're not available,
Yeah.
it's going to be a bit of a problem. This is the number one feature of a data store. And there is a lot of different ways that people think about database reliability. So it's things like, first of all, especially since we are doing our own storage manager, we actually need to make sure that every single committed byte is persisted to disk forever and ever. So this is obviously a big part of the game. And then there is machine crashed because AWS, there is a zone crashed, a
Right.
region is having trouble. So there's all those things. And then there is things like I did something as a customer that destabilized. Can Nile handle these things? There is
Yeah.
things like planned maintenance. We're going to upgrade the version of Postgres. Can we do it with zero downtime?
Yeah.
Can we move a tenant from one place to another with zero downtime?
Right.
So this is all things with various degrees of difficulty. Some
Yeah.
of them are well known and well solved. Some of them are a lot more challenging. Zero downtime maintenance in Postgres is challenging. So
Mm.
this is an ongoing journey to get there.
And why is that? Is that just because Postgres needs a hard restart when you do, let's say, a version upgrade, and there's very, there's no way to get around that, so to speak.
The hard restart is not the biggest part of it, because you
Mm.
can imagine us moving tenants to another database, doing a
Yeah,
restart, moving everyone back. It's more that transactional guarantees basically means that in order to do certain things, move someone from place to place, you need to make sure that there is no transaction in progress.
I see.
And in order to guarantee that there is no transaction in progress, in some point you have to basically make sure that take a look and make sure that no new transaction can start while you're flashing blocks to disk and moving things around.
Yeah.
So how fast you can do it is definitely an interesting challenge to work
Yeah.
with.
Yeah. One thing that kind of reminds me of is I'm wondering about what all the building blocks of Nile today are, right? So we talked a little bit about the storage layer. What kind of cloud components are you using under the hood? Are you doing continuous backup to S3? How do you do scale to zero? Tell me a little bit about that overall kind of shape of how Nile is deployed.
Yeah, it's honestly, it's not very fancy, so it's almost embarrassing to talk about in a way. But yeah, we are running on top of Kubernetes, and most of the automation is homegrown.
Okay.
And as an engineering manager, there's always the challenging point where you ask your team to look into different operators, and maybe there is something we can borrow and build on. And they spend 2 weeks looking at all the operator, and then they come and say, we have to write our own. And then you're like, did you actually do all the research, or do you just want to write your own operator because it looks like more fun than using someone else's?
Right.
But in this case, they actually made a good case for it, that a lot of what other operators do
Hmm.
assume a lot of things about the architecture, about how you do replication, about how you
Hmm.
do log shipping. And the
Hmm.
moment you separated the compute to its own layer, and you have a different way of moving logs from place to place and all that,
Hmm.
they are not as useful as
Hmm.
one may hope. So you have to write a lot of this infrastructure. And yeah, it's the fun of startup is that you always have too much to do with too few people to do it with.
Yeah, I'm not sure everyone would be super familiar with what exactly it means to separate compute and storage. So I'm curious if you can talk a little bit more about that and what it means for a database to scale to zero, especially maybe in the context of multi-tenancy.
Yeah, early on we mentioned that the basic structure that you can have blocks in memory and
Right.
then blocks on the disk. And scale to zero basically means that you no longer have blocks in memory.
Mm,
You no longer have blocks you still have blocks on the disk. They're not going anywhere. You no longer use any compute power, essentially, and you
mm,
no longer have that in memory. And this is different from the separation of computer and storage, is basically being able to have the physical blocks on the disk in one place and then spin up different computes and have
mm.
them start with blocks in memory from no matter, regardless of the fact that
Right,
you didn't have to actually copy data. They
right.
simply connect to this source of data and can start running queries and reusing compute if they didn't before.
Yeah, I think one thing I find interesting about these sort of cloud first architectures, like the one you're describing, is you can do a lot of interesting orchestration stuff and even just like cloud cost optimization stuff in the SaaS model. But how maybe disruptive or how much does it affect the like local testing environment? Obviously, your database is something that you're running in your maybe local sandbox, maybe on your Mac, maybe even like a CI/CD environment. So how do you think about that story with something like Nile?
This is a great question because it's something that I, as a founder, was very much blindsided by. Because we started developing it as a cloud service only,
Right.
essentially. And we're like, yeah, if you want a dev database, they are extremely cheap. Just create a dev database and yeah, and go to town. Why do I need to worry about local development experience?
Yeah.
I think it took me less than a month to basically do some pair programming with one of the engineers on my team.
Mm.
And then one of the things he did was spin up a local Postgres. And I'm like, this is how you're testing? And he's like, yeah, why? And I'm like, why don't you test against our dev environment in the cloud? And
Yeah.
it's, oh, it's okay, and I prefer to test that way. And I never got a good answer on why he prefers to test that way. But literally every developer I talk to prefers it that
Mm.
way.
Yeah.
So there is clearly something to be had about running a Docker container locally,
Yeah.
and maybe the ability to start it, stop it at will, or something along those lines that developers really, and apparently you cannot really move them away from that. And yeah, we are working on like single container image that will have Nile. So
Okay. Okay.
developers can keep doing that. We don't think it's going to be particularly good for production. You should still use our cloud service for production. But yeah, we basically like, okay, this we cannot, you cannot really change how customers want to do their job,
Right.
right? It's
Right.
their job.
Yeah. And it sounds like today, if I'm using Nile, I can still use the cloud offering for my dev database. I can also use a Postgres instance locally running on Docker, but having a Nile specific image will make sure that the programming model is fully consistent. Is that right?
It has a lot of benefits. So if you're actually using our SDK, that kind of
Mm.
allows you to take the identity of a user all the way from the browser to the database, then
Yeah.
you have to have our container because you
I
need
see.
actually our REST API services,
Got
essentially.
it.
If you don't, then I think probably a normal Postgres will be okay.
Got it.
Honestly, personally, I wouldn't trust it because I want to test on the same system that production will be on.
Exactly. Yeah.
But I think it should, theoretically, it should be okay.
Yeah. Yeah. Let's move to a maybe new topic that is hot these days, which is AI. Everyone's talking about AI. I know Nile, in fact, launched with support for embeddings at scale. And I think I want to learn a little bit more about how you think about Nile as a product fits into generative AI applications, maybe the RAG use case specifically. I know you all have published some content around that. But yeah, give me the kind of AI intersection with Nile.
Yeah, honestly, RUG felt really lucky
Mm.
because it's as a use case, you're basically going to, most use cases involve ingesting a lot of customer documentation and then letting customers do some kind of semantic search on it,
Hmm.
or maybe graph search, but similar
Hmm.
things. And it turns out that the one thing you really don't want is accidentally mixing up different customer data.
Right.
And, and a lot of people are still learning about things like vector indexes and so on. Vector indexes have massive scalability challenges. And suddenly we're like, you don't really need a vector index for all your tenants. You can get a vector index per tenant, and it's
Yeah.
going to be transparent. And guess what? We support it out of the box, and you don't have to do anything. And we didn't have to do anything either. It just worked.
Right.
That's what I mean by saying that if you get the architectural building blocks right, it's amazing what happens next,
Yeah.
essentially. Yeah, it landed on us as a use case. And obviously, we sell Nile mostly to new companies.
Yeah.
And it won't surprise you that a lot of them are very interested in the AI use cases. So yeah, we were a bit lucky that we give something that everyone wants, which is privacy between tenants applied
Hmm.
to RAG, and scalability applied to
Hmm.
RAG. And we didn't
Yeah.
have to do a lot to have it.
And I'm curious, is that something where people are using Nile for just their RAG use case, or is it that they're using it for mixed workloads and just like everything needs to be tenant aware or tenant isolated? Obviously, RAG also needs to be tenant isolated. How does that mix look?
We haven't seen anyone use Nile just for RAG, and
I
I'll
see.
be very surprised if I see it. I will not object, but it will be a bit surprising. The people who use Postgres for vectors is they pretty much arrive to that decision because they're like, I don't want to deal with other databases,
Yeah.
other clients. I just want to keep on using the thing I'm used to and now put some new type of data in it, and that's it. So yeah, everyone
Uh,
is using it for their entire SaaS.
yeah, and actually, maybe related to that, let me ask you a broader question, which is, as an industry, like how should we be thinking about specialized databases versus general purpose databases like Postgres, right? Is it, there's a bunch of offerings that are very specific to vectors, or even things like Elasticsearch is very specific to certain use cases. What is your perspective on this? Are those offerings going to persist? Is Postgres going to dominate maybe 5, 10 years from now? Pick your timeline. What is the future of the database industry, so to speak?
Yeah, I think they will persist. So there's a few things. First of all, there is use cases that are not your actual live customer-facing data.
Yeah,
So Elasticsearch will always be fantastic. Everyone uses, I don't remember, Beats to get their data to Elastic, and I don't see this going anywhere. Logs are going to go to Elastic forever. Same thing for specialized data warehouses or big data systems for the warehouse kind of stuff. I think
right.
this is forever.
Yeah,
For customer facing data, for me, it almost seems if you're asking this question, keep on using Postgres. The
exactly.
moment you need something else, you will likely know it. You
Yeah,
will know that, yes, I know exactly why I'm going to need this NoSQL system. I need Cassandra for reason X.
yeah,
I need PG vector is no longer good enough. I need ChromaDB for reasons.
right.
If you don't know any reason to use something else, I'm having a hard time. And how will you even choose? How will you even
Exactly.
evaluate, right?
Yeah, yeah. Awesome. This was a great conversation. I think maybe last thing I want to end on, which is what are you most excited about that you're building at Nile today? And it could be a feature release or some technical architecture problem you're solving. Let's wrap on that.
It's a problem being a founder because the thing I'm most excited about, I'm least allowed to talk about because
Fair enough.
we haven't made a big announcement yet. So yeah, I'm going to have to decline and say that wait for a big announcement.
Either way, that sounds exciting. Thank you so much for being on the show. I appreciate your time. And yeah, I appreciate all the technical details you were able to dive into.
Thank you so much. It's been a really fun conversation for me.
Awesome.